But 2.6 applications, again, applications just means that we're looking at word problems specifically. So some keywords for multiplication, we're looking at product. Of course, that would be the result of a multiplication problem. Times is also multiplication. Multiply, of course, that's a derivative of multiplication. But of, by, and doubled, yeah, a doubled is specifically multiplication by 2. Triple is multiplication by 3. And then, I guess quadrupled, if we saw that, would be multiplication by 4. Some keywords for division. Divide, of course, again, that's almost direct there. Quotient is the answer to a division problem. Split evenly, into, or per. Let's see some more of these, actually. So translating and solving multiplication and division. Yeah, we've just seen these, but one of the key ones I want to point out that we didn't see on that last slide is divide into. Just like when we saw subtracted from, if we saw subtracted from, it reversed the order and it wasn't so direct. If you see divided into, and it has to be in this order, by the way, right? Like we see in this example, 2 divided into 6 means 6 divided by 2. We're going to switch the order. Okay, again, that means it's more indirect. And hopefully it makes sense. We're gonna take something and divide it into some value, well, right? That's telling us how many groups we're going to split the, I don't know, amount into. But the rest of these are usually pretty direct. And multiplication, some people would say, well, if you say multiply it into, I'm trying to think how that would even work. But remember that, just like we saw in the last section with the commutative property, order does not matter with multiplication, which is why there's only the exception with division, right? Because division, the order does matter. Okay, but think about this too. 2 divided into 6 means exactly the same thing as 6 divided by 2. And, well, if you're thinking, that seems kind of jacked up, it is actually. It is jacked up. One thing you'll understand after a few classes of math is that us math people, we tend to say the same thing, but in different ways. And what happens to people's minds is they start thinking, oh my gosh, this person knows so much. When in fact, we're saying the same thing just in a different way, and it makes us look smarter than we are. I mean, yeah, when it comes to math, you could say, yeah, you're pretty smart, but, tell a math person, I don't know, change their oil and then would see how smart they are. But in any case, this is communicating the same thing, just in 2 different ways. Keep that in mind. We're going to see that more often than perhaps what we would want to in math. I mean, this is kind of saying that as well. So some translation and solving. This first one looks like it's that divided into garbage. It's not, though, because there's a number between the divide and into words. So if I were to read this, it says, what number results when you divide 196 into 7? So that means we're going to take the 196 and we're going to split it up into 7 equal parts. Okay, so that's 196 divided by 7. I want to show this with long division, though. Not because I like it so much, but, that's all we've seen so far with division. So 7, it won't go into the 1, but it will go into 19 twice. So 2 times 7 is 14. And so 19, we used up 14, so that's 5 left over there. So we're going to have to drop the 6 there as well. 7 will go into 56 evenly, 8 times total. 8 times 7 is 56. So see I did that one kind of fast. But again, we do kind of expect you to memorize those, at least first 12 multiplication facts. And yeah, when we do this long division stuff, that's really all we would ever need. If we don't see, or if it's a number beyond our first 12 multiplication tables or facts, then yeah, we just list them like we did in that problem from the questions from the homework. Oh, so I apologize. The number that we're looking for here actually is 28. So there's that one. The second one, the quotient of 42 and what number gives you 6? Let's go and write this out, okay? Now, it's talking about a quotient, and we know quotient is division. Well, it's the division of what? It's division of 42 and some number. So I don't actually know what the divisor is here, but I know 42 is the dividend because it was the first number listed when it tells us we're working with a quotient, right? It's the quotient of something and something. In this case, the quotient of 42 and something. We don't know what the second number is or the divisor, but we know what it gives us. It gives us a 6. So 42 divided by something is 6. And yeah, using the fact families on this one, we can solve this. And yeah, this is going to go straight into the division fact family. 42 divided by 6 would be, well, that's something. Right there. And yeah, you could do long division for 42 divided by 6 if you'd like. But you're still going to get 7. 7 times 6 is 42. Nothing remaining. Yeah. 42 is an exact multiple of 6. So looks like our answer here is 7. That is the number. And then we want to find the product of 14 and 23. So product is multiplication. So we don't really need to worry about the order on this one, although I still will put it in order. It's the product of 14, so that's the first number, the first factor, and then 23. So that's my second factor. And this is multiplication. So I'm going to move this over just so I have some space to work with. And what do I get? I got 14 times 23. And yeah, again, it doesn't matter if you put the 23 on top. You're going to get the same answer on this. So I'd say, all right, 3 times 4 there in the ones place value. That'd be 12. Carry the 1. Then 3 times 1 here. 3 times 1 is 3, but plus the 1 that we carried makes that 42. Now I'm dealing in the tens place value with the 2. 2 times 4 first is 8. And then 2 times 1 is just 2. No carrying on the second one. Add these two together and we'll have our product, which appears to be 2 plus 0 is 2. 4 plus 8 is 12. Carry that 1. 1 plus 2 is 3. So the product on this one is 322. But what number divided by 7 gives you 4? So what number, let's see, what number is dividing by 7? So that's direct translation right there. It's some value divided by the 7. There's a 7. But it's going to give us 4, right? Which means this equals 4. Now, again, we're missing the dividend, but we have the other two values, which means if I use the fact family on this one, specifically the multiplication part of this fact family, then I would take my dividend, the unknown. That would be the product of the other two numbers, which then become factors. So that's 7 and 4. Yeah, we need to multiply these out. Well, 7 times 4, that's just 28. That's not too bad. So it looks like the number on this one is 28. And then finally, this last one, the product. Well, there's product again. And we know product is multiplication. It's a product of 5. So there's our 5 right there. And some number. Well, we don't know what this number is, so I'm just going to use a blank. Gives you, so that's going to be equals 55 right here. So I'm going to change this into a division problem, and we know the product, the 55, is the dividend. So it's 55 divided by either one of those two numbers, two factors right there. I'll just choose 5 to make this easy. And what I get from this division is the quotient. That is the missing number. So we can do 55 divided by 5 using long division. That's no problem. 55 divided by 5. And yes, 5 goes into 5 once. 1 times 5 is 5. So we used up all 5 of those 10s. Drop this 5. 5 goes into that 5 once as well. So 1 times 5 is 5. And we see we have nothing remaining, which means 11 is our answer right there. That's the quotient that I got, 11. So before we do that, let's look at the area. In my mind, I'm thinking I said triangle. I meant rectangle. All right, so with rectangles, the unique thing about rectangles is you got two sides, well, two sets of two sides. And what we see here, that's not too bad for me on drawing my rectangles, but if you look at these two red sides like this, they're parallel. But that also means for rectangles that they're the same length. They have to be the same length for it to be a rectangle. And also these two sides as well. They're parallel. Not that we care what parallel is right now, but they're the same length. That's what we're really concerned about when finding the area of rectangles, is that these lengths, opposite sides of this rectangle, are the same. Now, it's very easy to get mixed up the area of a rectangle with the perimeter of a rectangle. Remember, we did perimeter problems. That's addition, where we add the lengths of the sides together, which gives us a new length. But area is talking about how much space or surface this area takes up. So how do we find the area of a rectangle? Well, what we're going to do is you got to take these two values, and I'm using L and W. L is for length, and yeah, I use lowercase l. But L is for length, W is for width. And in order to find the area, the only thing we got to do is take the length and the width, and all you're going to do is multiply them. That's it. Okay. Now, the other thing about area, not just of rectangles, but anything, whether you're looking at circles or triangles or squares or whatever you're looking at, okay, is that whatever units you get, units, now by units, I'm talking about units of length, right? Feet, meters, miles, centimeters, inches, doesn't matter. But these are actually considered square units for area. Because when we say square units, it means that if you took this rectangle and split it up into squares, and yes, my drawing's not going to be exactly squares, but I tried. So if you counted how many squares there are, that would tell you how much area this rectangle takes up. So that's why we call these square units. It is okay, by the way, to write this as units, but then we show a power of 2. And the reason why this is because you'd have units times units. I've done a better U, but that'll do. And this is just showing that it's repeated multiplication. Remember, that makes a base for exponents. So it's units, and how many were multiplied together? 2. These are communicating the same thing. Again, it's just showing it a different way. Which, again, is how us math people look smarter than we are. So this is how we're going to find the area of rectangles, and also how we're going to label. That label thing is going to show up in the homework, so you're going to need to know that. Find the area of a rectangle with a length of 25 feet and a width of 20 feet. So to find the area of this rectangle, right, and yeah, for some people it may be helpful to actually draw the rectangle out. It doesn't have to be proportional, right? So I'm not saying that I've like actually measured these out and said, well, it's scaled. Right, so I'd say, hey, this is 25 feet, and this is 20 feet. There's another way to show feet, just with the little I think that's an apostrophe like that. Could be wrong, but, I'm going to use a different color for that 20 right there, just to kind of color code things. I'll make that 20 feet right there. So we got these two lengths would be 25, and these two lengths would be 20, if you wanted to find the perimeter. But to find the area, we don't need all 4 lengths. We just need the length and the width. So I'd say, hey, we're going to take the length, which is, I'll say 25 in this case, and the width is 20. Well, this is just multiplying the 2, so I'm just going to multiply them, all right? Let's show the multiplication. 25 times 20 here. So I just need the product, and then I will have my answer. I got, first off, we got 0 times 5 is 0. Well, 0 times 2 is 0 as well. That's pretty easy. Then I'll go to the 2 in the tens place value, so no 1s. 2 times 5 is 10. And yeah, I'm doing this multiplication shorthand. You could expand these numbers if you wanted to. So I carried the 1 over. 2 times 2 is 4, plus the 1 is going to make that a 5. So it looks like our final product here is 0 plus 500, and it's 500. So the area of that rectangle there is 500, but we need to label it, right? So on this one, it's going to be square feet. And yes, I am too lazy to write the full word square out. Hopefully that's okay, but I think you should see it as SQ for square anyways. So when we find the area of composite shapes, we're going to need to keep that in mind, just like we saw in that homework problem, okay? So split the composite shape into smaller shapes. That's true. You can do it that way. There is another way to do it, and that is to really look at it as one giant. In this case, we're looking at rectangles, okay? But most students prefer to split these shapes up into smaller, I don't know that it's more manageable, but smaller shapes. So here we go, looking at this one, and yeah, we saw in the homework, you'll see maybe 2 or 3 like it. But the strategy for solving these is pretty much the same throughout. So if I said, hey, we're going to split this up, this means that I'm going to either cut it here to make 2 rectangles, or I would cut it horizontally to make these 2 rectangles, okay? All right, then it's settled. Let's chop this up vertically. Chop up sounds kind of morbid, but also satisfying. So on this one, we're going to make the vertical cut right here, okay? Which means I'm going to just, I am trying to trace that line. I feel like I didn't do too bad of a job on that one. But in any case, let's go ahead and take this rectangle. Well, we got 2 rectangles, actually, right? We got that red one, and then you see how it creates this other purple one right here? Okay. Now, what I'm going to do is I'm going to separate these. Composite just means that it's like 2 shapes pushed together. Like this one's 2 rectangles put together. So I chopped it up right here. And that makes the red rectangle. But it also makes this purple one right here. And so hopefully at this point I can separate these if it'll let me. So I can take the purple one and set it over here. And I can take the red one and set it aside. See, so now I'm really looking at 2 different rectangles. And once I find the area of the red one, I can take the area of the purple one and just add those 2 areas together. But I just need to know what their areas are. Well, what are the dimensions of these, right? We're saying, what is the length and width of these? That's how we're going to figure out the area. So I'd say, okay, I see over here the top of that shape, that's 2 yards. And then this length right here is 11. So there's 11 right there. On the purple shape, I get 3 right here. That's good. That's fine. But the problem is I don't have this side length of the purple shape, right? So I've got to figure that out. And here's how we do that, is I take the 2 yards up here, and then I just move it down here because it's related to that 7 yards. We've seen this before, right? So I'd say, look, that whole side length is 7. We used up the 2 in red, and then that's how much the purple is. 7 minus 2 is 5. So that gives us this length at 5 yards right there. So now I know the dimensions of the purple shape and the red shape. And I can find those 2 areas. So the area of the red there is 2 times 11, length times width, which is 22. Again, that would be 22 square yards, by the way. Well, I'm not going to worry about the label until we get to the final answer on this one. And the area of the purple shape, length times width, 5 times 3, which is 15. I feel like I didn't mention this, but math nerds everywhere, if you said that the length is the shorter of the 2 sides, they would freak out. So like if you ever just want to like freak out a math person, just say, hey, look at this length. It's the shorter of the two sides. And they will. I try not to. Maybe sometimes it gets to me. I don't know. But let's add these two lengths together, right? We got 22 and 15. Add them together. And this will tell us the area of the full shape. So 2 plus 5 is 7 in the ones place value. 2 plus 1 is 3. So it looks like our total final area here is 37. But it's not just good. It's not good enough to say 37 because we need a label for this one, right? This one is in area, which means it's square units, square yards specifically. 37 square yards. Bam, we did it. So let's look at this a different way, as promised. I said I'd show two different ways. Now remember, if that first way makes sense to you, just ignore this, okay? Like if you're like, man, I really like that. I understood it. I don't need a second way. Pretty much I'm asking you to like get up away from your computer and just take a break, okay? But if that last way was confusing, then this way may make a little bit more sense to you. Am I guaranteeing it will? No, I am not. But I hope that it will, all right? So what I'm going to do first off is to say, let's look at this thing as though it were just a big rectangle, one big rectangle. So I have these two long sides. I'm just going to just kind of make a full rectangle out of this, like so. And I can move this over, right? Now I have a rectangle, and I can find the area of this rectangle, right? It's an 11 by 7 rectangle. So to find the area of this one, it's just length times width, 11 times 7 in this case, which is 77. And yeah, I know it's in square yards, but I'm not too worried about that. Now, you may be thinking, hey, this is bigger than the answer we got from that last part that we did. That's true. That's because I included all of it, whereas, in fact, what we have here in red, like this, is not actually included, all right? All right, I'll say that that's decent right there. There's the red one. So, again, just combining these. So if I look at this red one, and I, just kind of compared it to the purple one, see how it fits in there? And then what do we get? We get the actual shape we're trying to find the area of in here. So whatever I have in red, since it doesn't actually exist as part of the area we're solving for, I just need to subtract it from the area of the purple. Okay, so I take the 77, I subtract whatever this area is on this red one. But I don't know what the dimensions of that red one are, so I need to figure them out. Now, just like we saw in the first method, which we're going to have to use the same method here, I got 7 yards here. At the top, I got 2 yards, which is 2 of the 7, which means the rest of it is 5 right here, okay? Which means that right now it's a 5 by something rectangle. And I'm going to use pretty much the same strategy to solve the other length. So I'd say this 11 right there. And this is 3 here. So the 3 would take up this part. And to solve for the red there, I'd take the 11 yards and subtract the 3 off the side. And that would tell me the other dimension. 11 minus 3 is 8. So the red rectangle here is 8 by 5. And again, I need to find the area of this rectangle here, which is 8 times 5. That's 40 square yards. So to solve for the total area of the original shape, I would take the area of the purple and the area of the red. Purple is 77 square yards. Red is 40 square yards. And all I'm going to do is subtract these. So 7 minus 0 is 7. 7 minus 4 is 3. And you see we get the same exact answer. 37 square, almost put feet on that, yards. Same answer, different method. And again, hopefully that worked out for you if that first method didn't make sense. Sometimes it does. There's not so many students that use this method, but every once in a while it will click better for some students than others. I definitely am not saying that you have to use one or the other. And you don't have to use the one that's the most popular. So choose which one you like and roll with it. These word type problems, one of the biggest things that students struggle with is really the first thing is, what order am I going to put these values in? And then the second thing they struggle with is, what operation am I using? Now, if you go back to the basics, and by basics I mean addition or subtraction, it can kind of help us to clarify what operation we should be using in this module, because, right, this module is based on multiplication and division. So if we can see repeated addition, then we should know that we're looking at multiplication. If we see, for some reason, repeated addition, not that we went over division like that, but technically it kind of is, repeated division is repeated subtraction. I think that's what I meant to say. So if you see repeated subtraction, then just know that you could be using division instead. Now we'll see some cases where it's not convenient to use subtraction or addition. So we may just jump right into the addition or the multiplication. But again, it's all about knowing when to use it, and the sooner you can use it, the more convenient things become, right? Like this one, it says Jenna swam 4 laps. Each lap was 75 meters. How many meters did she swim? And for these word type problems, it may be useful to, I don't know, draw a picture of this. Now, this is talking about swimming, which I'm not very familiar with. And so for me, I would think laps, I think more like a track, right? Okay, so you got a track like this one. Actually, that's not too bad of an oval for me. So, you know, if you started right here or wherever the heck you'd start with on this track, whatever, you'd say, oh, you're going to go around once. Boom, that's 1 lap, which would be 75 meters. And you'd go around another lap because, right, Jenna's going 4 laps. That's another 75 meters. And then another lap, which is another 75 meters. And then another lap, which is, well, another 75 meters. To find out how many total meters she swam, we could add those together. But remember, as soon as we realize that we're just doing repeated addition on this case, then we should know that we can go directly into multiplication. So I would take those 75s. I got 4 of them, which means I can just multiply it by 4. And whatever this product is should be what we would get from 75 plus 75 plus 75 plus 75. So I'd say, you got 4 times 5, which is 20. So there's the 2 there, carried the 2. 4 times 7 is 28, but plus that 2 right there would make that 30. So this would be our final answer, except we need a label, right? This one's in meters. And yeah, you can just use an M for meters. Just don't put an I after it, then that would be miles, right? And we should, since we're starting these types of word problems, we should always expect to be labeling these answers when we see word problems. Always expect to label answers. So Danny paid $65 a month for 4 years for internet service. How much did she pay in total? So yeah, this one would be, I don't know, I think this would be kind of rough to figure out how much he paid after each month, because it's 4 years. And this is one thing that can confuse some students, right? It's $65 a month, but it's just for 4 years right there. And it's not the same units of time specifically, right? We're saying, hey, you're going to compare months to years? Well, you can. We just need the same measurement here. So one way to do it, and this is the less typical way, and so I'm not going to do it this way. I'm going to do it the other way. But some students would say you do 65 times 12 because you know that's how many months are in a year. 12 times 65, whatever that product is, you'd multiply it by 4 because it's for 4 years of internet service. And that's how much you would pay in total. And that would work, by the way. But what I prefer to do, and I don't know, this is what I've seen most students do in the past, is they say, I'm going to take the 4 years and convert it into months instead. This would tell me how many $65 payments that I have. So 4 years, I remember there's 12 months in a year. It's supposed to be an M. Months per year, right? So if I multiplied that by 4 years, then I would end up with some number of months. 12 times 4, 4 times 2 is 8, 1 times 4 is 4, 48. So 4 years is the same as 48 months. Or in other words, you got 48 of these $65 month payments, which means it's like having 48 groups of 65. It would work the other way, by the way. So I'm going to take the 48 months and multiply it by $65 per month. And whatever I get from this multiplication, this product will be how much money she will pay total. So working in the ones place value, I got 5 times 8, which is 40. Let's carry that 4. And then 5 times 4 is 20, but add the 4 makes that 24. Then I'd be working with the 6 in the tens place, so no ones. And 6 times 8 is 48. Carry the 4, it's another 4 carried. 6 times 4 is 24, but plus that other 4 makes that 28. So again, it kind of offsets that value right there in the thousands place value. And when I add these two together, this will tell us how much Danny paid in the 4 years. So 0 plus 0 is 0, and 4 plus 8 is 12. Carry the 1. 1 plus 2 plus 8 is 11. Carry that 1. 1 plus 2 is 3. Now, again, that was a lot of work right there. It's like, whoa, that was a lot of work. In fact, if you do it in different colors, it looks pretty, like mine does. But it's not enough. It's not enough, okay? Because it's a word problem. And remember, like we talked about in the last slide, when we see word problems like this, we should expect a label. So it's not just 3,120. It's how much did she pay. That means that we're going to be labeling this in dollars. So our final answer here is $3,120. And again, while it may be labeled for you in the assignment, some students like to actually write the word out dollars here, and that would be fine. It's just more work than just writing the S with the line through it. Remember that when you're looking at these word problems, I know I'm kind of doing these pretty straightforward and almost kind of fast. It may take you several times of reading these, okay? And I say several, meaning 7 or more times. And if that's you, don't feel bad about that. It's going to take a lot of patience to get through these types of problems until you get used to them and can do them at a faster rate. You know what I'm saying? So don't be discouraged by the length of time it takes these, or even if you see other people doing them faster, right? Remember we talked about that at the beginning of the year with schema. Like if you have the background in this kind of stuff, then yeah, you could probably do these fast. But if you don't, we will expect it to take you a little bit longer.
All right, Jake hiked up a mountain for 3 hours. Each hour his elevation increased by 70 meters. Compute his change in elevation in meters relative to his starting point. All right, so it says each hour he's going to increase his elevation by 70 meters. So elevation means that here, we'll just say he starts at some 0 meters here, and then for 1 hour he's going to go up or increase his elevation in some way by 70 meters, right? So that would be 1 hour right there. But then after 1 other hour, he would increase it still another 70 meters. And that would be the second hour, and then of course the third hour, 1 more hour, another 70 meters. So how many total meters did he change his elevation by? Well, it's just the total of all those 70 meters. We just need to add those together. So 70, well, you could just start in the ones place value, 0 plus 0 plus 0, which is 0. And then here you have 7 plus 7, which is 14, plus 7 is 21. So 210 meters is the total amount of elevation he increased from his starting point. Now, I did use addition on this one, but you could have just used multiplication. You could have said, well, look how many times he's going to go up 70 meters. It's for 3 times, right? Because it's 3 hours. And it's really 70 meters per hour. So that means that you could have just taken 3 groups of the 70 like this, 3 times 70, and multiply those out. So you'd say, okay, 70 times 3, 3 times 0, 0, 3 times 7 is 21. And you'd see you'd end up with the same answer either way. But again, don't forget to label the answer here in meters.
So Vonne bought a total of 180 t-shirts. If there were 6 t-shirts per package, how many packages did Vonne buy? Well, we know there's a total number of t-shirts. Now, if it's 6 t-shirts per package, and we want to know how many packages there are, it's like saying we're going to distribute the 180 into 6 groups. And while I know it's just 6 t-shirts per package, however many groups is, how many ever packages are in one group or in the group, well, it would tell us how many packages there were. So this is a division problem, right? We're splitting the 180 up into, well, different groups. I mean, they're the same size groups, but different groups. So different equal groups, that may sound better. But since we are splitting the 180 up, that means we are using division. Particularly, we're starting with how many that is going to be distributed or split up. That amount is the dividend. However many we're splitting it up to, that is the divisor. So we're going to split this up into 6. So it's 180 divided by 6. And yeah, I'm going to split this up, or I'm going to not split it up, but I'm going to use long division to solve this one. 180 divided by 6. 180, the dividend goes in the division, long division, and then the divisor is on the outside there, the 6. Well, 6 won't go into 1, but it will go into 18 exactly 3 times. Because 3 times 6 is actually 18. So we used up all 18 of those 10s, right, which makes 180. And so we don't have anything left over there, but we do have the 0 right here. And yeah, 6 is not going to go into 0. It's, well, 6 divided by 0. How many zeros are there in 6? No, I'm asking that backwards. How many 6s are there in 0? There's none. So we get a 0 out of that. 0 times 6 is 0. You could say you got 0 remaining, but that, I think that last operation there on the long division was obsolete. So 180 divided by 6. Yeah, I'm going to get rid of that 0 just so this looks pretty. We get 30. Oh, I made a mistake, didn't I? Forgot to label it. Yeah. It's not just 30. In this case, it's how many packages. It's 30 packages. Let's see if I can fit that. There we go. 30 packages. And on this one, Jose is driving home for the holidays. His home is 490 miles away. If he drives for 7 hours, how fast did he travel per hour? So that would be miles per hour. There's the per. That sounds weird, but per word indicates we're using division on this. Per hour specifically, we're dividing it by the hours, which was 7 hours. What are we dividing by 7 hours? The miles. 490 miles. 490 miles. And this will give us miles per hour, which is, of course, a speed, a rate of travel, I guess. Sure. Well, that's 490. That's our dividend divided by the 7. So that's how this sets up. And again, we're using long division because that's what we've seen in this unit. So 7 won't go into 4. It's not big enough. Excuse me. But if I look at it at 49, yeah, that'll work. 7 will go into 49 exactly 7 times. And 7 times 7 is, well, that's exactly 49, just like we said. So let me get rid of that 0, clean this up. So that's a 0 right there. But let me drop this orange 0 right here. How many times does 7 go into that orange 0? None. It won't go into it at all. So that's our number. But the next thing we need is the label, right? So that's 70. I'm just going to put MPH, which is a very common label for miles per hour. You could write it as a fraction, but I think that would make it probably more confusing than we need it to be right now. So yeah, that's 70 miles per hour. That's how fast it looks like Jose was driving home for the holidays. And some of you may be thinking, well, that's kind of fast for the holidays because sometimes it gets a little snowy. Okay, perhaps. Whatever. Together, 9 friends have $99. If they share the money equally, how much does each friend get? So how much does each friend get means that we're going to be splitting up that 99 bucks among 9 people. And splitting it up indicates that we would be using division. Or, yeah, it says they're going to share it equally as well, which also indicates division. Well, that means we're going to take the 99. So that's our dividend, rather. Our dividend is 99. That's how much is going to be split up. The 9 friends, that's how many groups it's going to be split up into. So whatever we get from this division problem will be the solution to this, or the quotient to this division problem. Let's go and write this out with long division. 99. That's our divisor. So it goes inside the long division. Divided by 9. So the red 9 will go into the blue 9 once. 1 times 9 is 9. So subtracting that out, that eliminates that tens for us completely, right? There's none remaining. So I could drop the blue 9 in the ones place value, and the red 9 will go into that blue 9 still 1 time. So 1 times 9 is 9, yeah, and that eliminates all of the value. There's nothing remaining. So we get 11 as our final quotient, but again, we do need to label it how much, when it says how much, it was talking about dollars here. So the label on this one is in dollars. Each friend will get $11. John is baking apple pies. He has 151 apples, and each apple pie requires 7 apples. So what is the maximum number of pies John can make? Now, I talked about the beginning of these word type problems that you could use either addition or subtraction. What I mean by that is if you just took away 7 out of this 151 and that subtraction, then you could figure out how many pies John is making. But when you do that, when you use subtraction, which would be repeated subtraction in this case, you can also use division. Now, of course, you could just say, well, we're going to take the 151 apples and distribute it amongst 7 each, right? So you just say, it's divided by 7, and this will tell me how many pies it is. That is also true. So either way that you look at it, you should know that we're going to be working here with division. Particularly with 151 apples, that would be our dividend. So that's the first number in the division problem, and we're just going to divide it up with 7 apples. So it's 151 apples divided by 7 apples, but that really is a rate at 7 apples per pie, which is why our answer will end up in pies in this one. So let's do this again, long division, right? 151 divided by 7. Well, 7 won't go into 1, but it will go into 15 twice. Oh, yeah, the other thing about this is it says how many apples will be left over. We know we've only seen leftovers with division, right? So that's another reason. Just being able to see that, I think, is actually a higher skill than math is, but just knowing that there's some left over and you would know that that's division, that's a good skill to have. 2 times 7, by the way, let's go back to the long division. 2 times 7, that's 14. So we used up 14 of the 15 in the tens right there, which would give us a result of 1 left over. Let's drop the 1 in the ones place value, though. So now we got 11 apples left over. So I'd say, well, 7 will go into 11 once, right? It can only go into it once. If I said twice, it's too much. 1 times 7 is 7. So when I subtract this out, this will tell me how many apples remain. 11 minus 7 is 4. So first off, up here, that's 21 pies that can be made from those 151 apples. But you'd have these 4 left over, not just 4, but 4 apples. Jerry is sending care packages to troops overseas. She baked 93 cookies. She wants to share the cookies equally among the 8 different troops. How many cookies will each troop get? And then how many cookies will be left over? Again, if you've looked at this second part and said, it's asking about a leftover, that's also a remainder, which means we're using division. That'd be fine. But we are dividing 93 cookies up with 8 different troops. So either way you look at it, right, it's sharing these equally, which means that we're going to be dividing them up. So just from either way that you look at it, you should know that we're looking at division. Well, what are we dividing? We're dividing the 93 cookies up amongst 8 different troops. So 93 is our dividend, 8 is our divisor. Now, if you can do that division in your head, that's super awesome. But I'm going to use long division in this, right? 93 divided by 8. So, using the long division, 8 will go into 9 once. Not exactly, but almost. 1 times 8 is 8. When I subtract that out, that's how many of the 10s I have left over. So I will need to drop the 3 and make that 13 then. And how many times will 8 go into 13? Once again. I've seen a lot of 11s, probably more than I expected. 1 times the green 8, the red 1 times the green 8, that's 8. So we used up those 8 from the 13, which leaves 5 left over. So that's our remainder. So how many cookies will each troop get? 11 cookies. I made it with the label there. It's 11. And the remainder 5, that's how many cookies will be left over. 5 cookies left over. And I really hope the real question here, which again I think is a higher order of thinking than with the math we've gone over, but some of you should be asking, how the crap do they have 5 cookies left over? When have you ever seen 5 cookies left over? I don't know. Only in math, I guess.